Hi, it's me, Tim Dodd, the Everyday Astronaut. 2 flights in 24 hours, hopefully. This is an exciting day, and I'm actually extremely double, triple excited about this launch. This is the 10th flight of Rocketlab's Electron rocket, and they're going to be testing out their actual re-entry and recovery systems, putting them through the paces. So, of course, like always, let's do a little bit of this. I better get that countdown clock back up, though, and there we go. So that we have that up there. We are about T-minus 30 minutes from this launch. Now, I do need to warn you, they are still tracking ground winds. They have a pretty big launch window, but let's go ahead and go to this little website, everydayastronaut.com, click on the pre-launch previews, and then we just click on the mission that's next coming up in, as you see, 30 minutes. We can click right on this baby here, ta-da, and look at this. This is our pre-launch preview for this mission. This is the Electron mission called Running Out of Fingers. It's subject to change, as you guys may know if you've ever watched a rocket launch. There's always things that can happen. So December 6th, that's today, for most places, at least in the U.S. Sorry, West Coast. December 6th, 2019 at 7:56 UTC. That's 2:56 Eastern. And locally time for New Zealand time, it is 20:56. The mission name is Running Out of Fingers because it is their 10th mission, and Rocketlab loves to have fun when naming everything. What's wrong with the overlay? What's wrong? What about it? It's showing this morning's launch? Oh, the overlay is showing this morning's launch. Huh. Guess you forgot to update that. Anyway. Okay, so, yeah, wow. Okay, well, this is just like me throwing a steel ball into a window and having it break unexpectedly. All the oxygen is going to get sucked out of the room. Okay, so this is running out of fingers. Again, that is something that Rocketlab likes to have fun when naming their vehicles or their missions. And this is a rideshare mission that's organized by Spaceflight Industries. The launch provider today is Rocketlab, if you haven't heard me say that 5 times. The customer, there's 2 actual customers. There's Alba Orbital and Ale Company Limited, in parentheses, Ale. The rocket today is their Electron rocket. That is the only rocket that Rocketlab has period, and has ever even remotely talked about. There's never been any even whispers of any kind of, Electron Heavy or Electron Plus or Electron Mega or anything like that. They're pretty darn happy with this vehicle. It's servicing the market and providing dedicated rideshare. So, yeah, I don't think they have any plans to do anything other than that. This is taking off from Launch Complex 1, or LC1, in the Mahia Peninsula in New Zealand, which is awesome. This is probably the most gorgeous launch complex in the world, although they're right about to open up LC2 in Wallops, Virginia. So that's pretty exciting. The payload mass today, this is 77 kilograms. It's about 170 pounds. That's not very heavy for how the Electron can handle about 250 kilograms to low Earth orbit. These are going to low Earth orbit. They will not actually be attempting to recover this booster yet. They're testing it, though. They are working on it. It does have hardware on it for recovery and reentry. It will be trying to see if it can survive reentry. And yeah, that's going to be really exciting. They did promise that they'll actually even have cameras on board and try to stream what they can. So I'm just excited because this is the first time, or this is the first time since SpaceX has tried to recover an orbital rocket. So this is only the second private company, the second time really ever, if you don't consider the space shuttle, which you should consider the space shuttle reusable. Let's just make that very clear. That was very clearly a reusable vehicle. So I guess besides the space shuttle, then of course the Falcon 9 was the first liquid-fueled propulsive orbital class booster to propulsively land. That's kind of what you have to say in order to, orbital class, because actually New Shepard landed propulsively liquid-fueled. So orbital class liquid-fueled propulsive landing reused booster is the Falcon 9. This is hopefully, maybe if with any luck, this will be the second orbital reusable rocket, and this is the first step of that. Sorry, that was a long little mini rant there. So no, they are not going to actually recover the stage, but they will be testing its reentry and see how they do. This stage will crash into the ocean. They don't do any fairing recoveries. This is the 10th flight of an Electron rocket, the 6th launch of Rocketlab in 2019, and the first flight of the upgraded rocket. And here's our beautiful infographic by Jeff Barrett. So be sure and check that out whenever you guys, if you need to get this rundown, you're like, oh, what's the next mission? Just everydayastronaut.com/pre-launch preview. We've got you covered. This article was written by Austin DeSisto, who is a Discord Patreon member who's been helping out. Now we do have a nice little team of people helping out, which makes this so much better. So give Austin a thank you. Also, we do have, I noticed some tweets here. We have some updates. I'm just checking Rocket Lab's Twitter account. 19 minutes ago, they did say Electron at sunset, which is just beautiful pictures. But this is the more important one. Today's launch window is open. What is that? That's about, 1 hour and less than an hour and a half. So we have some time. But the ground winds are a consideration. So in other words, like literally just too strong a wind. You can't have it be too strong a wind or else it'll blow the rocket around. That's not a good idea. And so there's still consideration as they get closer to the opening of the window, but currently they're tracking green for launch, which is quite exciting. So, so there you go. Now you guys know what's going on. How are you guys? I feel like I just was talking to half of you earlier today. I'm going to get rid of this overlay again now that I know it's wrong, but that is the right time. The time is right. We are 24 minutes until launch. I'm done with my rundown. We just get to hang out because I don't exactly know when they're going to live stream. How is everybody? Mo E on YouTube asks, did I visit the Baron when I was in Germany? I have not seen it yet. I was actually pretty close, but it still was like a 4-hour drive and 4-hour drive back to where I was. I'll go again though. Like I feel like at this point I'll be in Europe at least once a year, and I will go visit Baron someday. So Yeah. Yeah. Ooh, Eddie Mercury. What a great name. Is in their normal hat and full flow stage combustion cycle shirt. You're in good company. I'm wearing my F1 shirt tonight. And an everyday astronaut hat, so thank you. Yeah. The Salty Gamer wants to know, what do I think about rods from the gods? Can you explain the mechanics and feasibility? I don't even know what that is. If you're talking about the whole orbital thing that everyone's talking about, because what's his name on YouTube did a really good video on it, the whole skyhook type of thing. Sure, someday, but it's going to be a long time before we develop anything like that. I don't exactly know. But yeah, it sounds like they're going to be going live in about 2 minutes. I've got their thing pulled up here. Yeah, we'll probably hear music from them shortly. Yeah, so how are you guys? So maybe I'll do a skyhook thing, but I feel like that's a big hot topic right now. I don't need to ride the coattails of that. But yeah. Speaking of shirts and merchandise, don't forget for the holiday season, guys, I do have some new shirts up. This one is a holiday exclusive. It'll be gone. We're almost out of it already. So if you want an awesome little ode to Delta 2 that also looks just a little bit festive. Why does it do that? Get up. There we go. There you go. Ode to Delta 2. This one does not have one of those cool little patches like the F1 shirts do. The shirt I'm wearing has like these sew-on patches, and that's like my new favorite thing in the entire world. So if you want, these ones are like a little cooler in my opinion because they have this. Look at that. So cool. 1,522,000,000 pounds of thrust. Sorry for going. I did go Imperial on that because you kind of just have to when you're dealing with the F1. It'd just kind of be a shame. Yeah. Anyway, we also have some sales open in the RUDS, the Rapid Unscheduled Disassembly section, or Rapid Unscheduled Discount section. Sorry, I'm actually used to saying it that way. I did add the science hoodies, and science t-shirts are on sale until we run out. We're almost out of hoodies. We've got a couple t-shirts left. The old F1 shirts without the cool tags are in stock here, 2 on sale. Closing out on the Falcon Family Tee. So hop on here. These make good Christmas gifts, good holiday gifts. And if you buy anything before the 15th, it'll be there for the holidays. And also, while I have you guys, I am also, if you're in Austin or want to go to Austin for any reason, I'm going to be doing an episode of Our Ludicrous Future, the podcast that I do each week with my friends Joe Scott from Answers with Joe and Ben Solons from Teslanomics. That's me, the jabroni in a spacesuit with freaking Rich from Rich Rebuilds, who I'm a super big fan of. That guy is awesome, so I'm stoked to hang out with him. But I'm actually we're going to be doing this live. We're going to do a live recording of Our Ludicrous Future. I'm also going to do a talk about the pollution of rockets, and this will be February 1st and 2nd in Austin, Texas. Go to fullycharged.show and click on events, and you can get your tickets now before they sell out, and come say hi. That's going to pretty much do it for my pre-show ramble. As we're still waiting, who knows how long? Oh, they did push it back to 13 more minutes. So maybe they're just hoping for better ground winds. I'm going to just double check their Twitter feed here, make sure I didn't miss anything. Okay, so countdown hold at 30 minutes. This was 3 minutes ago. Let me pull it up and we'll read it together. What's the fun in that? Countdown hold at T-minus 30 minutes to allow for ground winds to ease. The window remains open until 9:22 UTC, so hopefully that's not that big of a deal. So we are in a 30-minute hold. I believe our countdown clock is not going to be accurate anymore. And it's just in a hold too, so we don't really know. So I'm going to go ahead and turn off the countdown clock so that we don't have any of those, any false impressions. And there it is again. Get out of there, Mr. Clock. Okay. Anyway, how are you guys? Okay, so Night Fox, these Australian launches are so close to my time zone. I'm at work. Well, don't forget, this is a New Zealand launch, so don't say that too loud. Also, thanks, Night Fox. Valdemar Thor Johansson. I tried. Hey, greetings from Denmark. Well, hello, Denmark. Thanks for joining. Jazzy Mac, when this works, it'll be amazing. I still get goosebumps when Falcon lands. So awesome. Did you see the update on Parker's solar probe? We've already learned more. No, I have not seen the update from Parker Solar Probe. I don't know if you guys remember, but Parker Solar Probe launched last year, right? On top of a Delta IV Heavy. That wasn't this year, right? No, that was last year. Definitely last year. Launched on top of a Delta IV Heavy, and it's the mission that's doing these very eccentric orbits, zipping by the sun, getting closer to the sun than we've ever been, which is pretty freaking awesome. So, yeah, I'm excited to see data on that, see science that they have figured out, because, you know, when you get something closer and study the actual outer atmosphere of the sun, hopefully we learn a lot more. That's super cool. And I agree with you. When this works, it's going to be amazing. And I don't know if you guys know about the reusability plans. I do have a full video on it. Let's see if I have a link to that here. Let's see here. Yeah, so this is their plan. They're going to be trying to catch it with a parachute or using a first hypersonic balloon that will get it from, you know, hypersonic speeds down to supersonic speeds. And then eventually they'll pull a parafoil or a steerable parachute. And then it'll slowly glide and steer itself in a straight line until this helicopter will come by and swoop it up. And I know you might think that sounds absurd, but don't forget, this thing is tiny. Like, this is me and it. It is a very small vehicle. It's only weighs less than, it's... Oh, crap. Yeah, it's 950, maybe 1,000 kilograms now. Before the recovery hardware, it was 950, so maybe now with some recovery hardware, it's over 1,000. But it's a very, very lightweight vehicle, nice and small. And so it'll handle a parachute a lot better than, say, something like a Falcon 1. And also the style, this has been totally proven out. There was a video here. You need to just watch the video that I put together because I kind of do all this rundown. But this place called PDG Aviation Services, I've already practiced this exact thing and nailed it down with a significant amount of success. And that's the exact system that Rocketlab is hoping to deploy. And if they do so, then they'll just lay it on down on this little boat here with some little robot arms. I'm stoked. Yeah, it's going to be cool. And of course, air recovery is nothing new. I talk about it in this video that we used to capture Corona satellites, the US did, out of the sky with a freaking airplane, swooping it up with a parachute. Pretty awesome. Big fan of that. So I really hope this whole system works out. It'll be super, super cool if it does. Of course, parachutes on suborbital things, like Electron's booster and, of course, the Space Shuttle solid rocket booster, it can work. And again, SpaceX tried it with their Falcon 1 and Falcon 9 unsuccessfully. And this is the other thing that's really crazy, actually. I was able to chart out thanks to flightclub.io. That's Declan Murphy's website where you can get freaking data on every rocket and it like simulates it perfectly, or darn near perfectly. We can actually chart out here the different vehicles. So the Electron is red. Look at how high it actually kicks up that second stage. So it's actually going higher than a Falcon 9. Falcon 9's a little bit shallower. This is a pretty standard Falcon 9 mission. I don't exactly remember which one. I do talk about it in the video. But then, yeah, and the SRBs from a space shuttle, barely even, like, the highest they ever get is 65 kilometers. They don't even get to the edge of space by the definition of the Kármán line. Space shuttle solid rocket boosters are just whoop, and they like barely do any work. They're basically just to help get the shuttle off the ground because, yeah, then those three space shuttle main engines, the RS-25s, just would kick it the rest of the way into orbit, burning for a full 8 minutes. Those things were beasts. But what's really interesting, this is about how far the Vulcan booster is going to go. Look at that. It burns forever. Yeah. And then it'll light up its Centaur upper stage. And that's the first stage has to do that much work on something like Vulcan because the Centaur upper stage is very weak when it's powered by a single RL-10 engine. It's very underpowered, but it's very, very, very efficient. So it makes up for it. So once you get that thing into orbit, you'll hopefully have just an absolute abundance of Delta V and abundance of fuel. So yeah, okay. Let's keep talking here, guys. How are you guys? Let's see. Okay, so Chazzy, thank you. Iconium, pointy end up check. Based on the data given to me in this, let's actually analyze this for a second. Okay, we got the pointy end. We've got like the not as pointy end there, and I think flames come out there. Divide by 3. Take into account the azimuth. It's upside down. Oh, this is really tricky, actually, because honestly, this is launching from New Zealand. So is this photo upside down? Did they pre-flip it? I don't know if I'm certified to determine whether or not the pointy end is up and the flaming end is down for a launch on the Southern Hemisphere. I might have to get a different certification for that. I don't know if I even want to go there. Whew. That's beyond my pay grade. So we'll see. Hopefully they have a rocket orientation specialist on hand. That isn't me. But thank you, Iconium. The LOL Minecrafter. I'm just curious, but did you ever manage to keep/steal that spacesuit boy that you try on? You said so yourself. The Soviet suit is a nightmare to have to wear. Never hurts to get an upgrade, right? I was unable to sneak out the door with the Boeing spacesuit. I'm sure that spacesuit costs more than everything I've ever had in my life combined. I can only imagine that's a $500,000 suit or something like that. I don't know. I don't actually have those numbers. I would be curious on those numbers. Maybe it's not that expensive. Maybe it's only $100,000 or $200,000 or something. But it is a high tech piece of garment that has to do more than just look cool. So no, I was not able to steal one, unfortunately. And I don't recommend stealing for anyone anything. So, and don't forget, if you haven't been able to notice, I really am like literally done with that spacesuit. I wore it too much, especially it was over a year ago. It was almost a year and a half ago. No, it was almost 2 years ago. It was early 2018. I did a show for Facebook Watch, which was kind of like Facebook's original programming, Netflix, Hulu, their competition for that, or like YouTube Red or YouTube Originals. And I did a show that was called Spacing Out with the Everyday Astronaut. And I wore that spacesuit every day of filming with, film crew of like 6 to 10 people. We went around, did all these shots for about 2 weeks. I wore it for 8 to 12 hours a day. And also I took the character of Everyday Astronaut like way up to the absolute stratosphere. And I wore myself out with it. And quickly, pretty soon after that, by the time the show actually came out, which was like, I don't know, July or August or something, I was sick of I was totally like over the suit. That was definitely the nail in the coffin because I just was tired. I didn't want that. I had this theory come up of, has anyone ever clicked on someone's video or did anyone ever click on someone's video and say, I'm not going to listen to this guy, he's not wearing a spacesuit? Odds are literally maybe one person ever, but the opposite is true, where I guarantee a lot of people were clicking on my videos and going, why is this guy wearing a spacesuit? And then they just click out. They just nope out, not even give the information a chance. And just to bring that barrier of entry down and to make sure I'm just a normal person, just everyday astronaut, that's why I haven't been wearing the suit, and that's why the suit's done. I just like being me, and I hope that it removes that barrier of like, huh? What? It should have stayed an art project, because it was originally, the whole Everyday Astronaut thing was an art project first and foremost. It probably should have just stayed that way. It probably shouldn't have come over to YouTube. But, I'm happy now. Hopefully you guys are too. All right, so, Law Minecrafter. Let's see. Chad, keep up the great work. You make space incredibly exciting for everyday people, and I'm so glad to be here for the ride. Hey, awesome, Chad. Thanks for hanging out. Thanks for joining us. And hopefully we get to see a rocket launch today. Another one, because we already got to see one. Yeah, My Radar, thank you for the new membership. Harry, how's it going, man? Harry Stoltz. Hey, Tim, it was great meeting at the Starship event back in September. Clean Tech. I know who you are, Harry. I've been meaning to catch one of your streams. Well, welcome. You're West Coast, I believe, if I remember right. So it's not too late for you. Hopefully this thing goes off here relatively soon, and we can all go to bed at a reasonable time. So thank you so much, Harry. My Radar. Whoa. Okay, first off, thank you, My Radar. That's very generous. Everyone, please thank my radar on my behalf. They say, just tuning in to watch you tonight. Our satellite is part of the payload tonight. Awesome. Everyone say thank you to my radar. I'm curious which satellite, again, there are two of them on this bird today. I'll try to see if I can catch I'm getting an error on chat. Let me see if I can pop that out. Let's see. Okay, so my radar, I'm going to try to keep an eye open and see if I can't catch you. There we go. Huge fan of you for a while. Falcon Heavy Launch, my radar. Which satellite is it? We're going to cheer extra loud for you. That is so cool. And seriously, thank you. That is unbelievably generous. You did not have to do that. But we're really, really excited for you to have a freaking satellite in space. Can you imagine being someone that puts together a satellite and then watches it go to space? I mean, that's absolutely incredible. So everyone keep an eye out for him or them, sorry, and let me know if they are from Alba Orbital or Ale Company, because I am very curious. But still, regardless, thank you again. You're awesome. Yeah, geez. All right. Okay, there we go. Ours is the TRSI My Radar's Pocket Cube on the Alba payload. Super, super, super cool. All right. Well, there we go, guys. We now know someone that is putting a freaking thing on top of a rocket today, launching it to space. That is awesome. That is super cool. Oh, and that's super cool. They also are doing an app. That's very, very, very cool. Sweet. Well, thank you, my radar. That is awesome. Evan. Hi, Tim. I ordered some of your shirts last week. Had to contact store because I never got confirmation email. Love the last shirts I got. Happy holidays to your family and your support staff. Thank you so much, Evan. Yeah, anytime we have those big rushes like holiday sales, when I interviewed Elon and our store just about exploded upside down, and especially at the time, the guy that runs my shop had a baby literally like the day before I interviewed Elon Musk, and then our interview came out and he was still just like not in the shop, and they just got totally flooded with orders. That was like the busiest the store's ever been. So for those of you that ordered during that time, thank you. And thanks for your patience, because there's just a small team of people. There's basically a full-time person that runs a shop for a living. That's what he does. He does printing and fulfillment for like all these companies. But then we just have a couple handful of people that try to share the load, and sometimes we get slammed. And so I think that if you ordered during Black Friday through Cyber Monday, those orders are going out this week, and it'll now be Friday. So yeah, so hopefully you'll get order confirmation by the end of the week, and I know those will be in your hand really soon, and I'm really excited because I'm personally stoked for this new run of shirts. I can't wait to be wearing them. Okay, science out there. Hello from South Dakota. Up late with your fiance, sorry, I can't read right now. It's too late. Hello from South Dakota. Up late with my favorite Iowa tuber. I hope that's me. Maybe you're with someone else. It's an Iowa tuber. Hold, or I'm sticking with you and Rocketlab. Let's catch this candlestick. Yes. Well, they won't be catching the candlestick today, but they will be seeing if the candlestick can survive Earth's punishing atmosphere. So thank you very much, neighbor. And thanks for saying hi. Peter Martin. Tim, what was second piece of debris at 110 seconds, about 10 seconds after nose cone deployed? I blabbed on Lab Padre, and you're the go-to guy. Good job, bud. Okay, let's find out. Let's take a look at CRS 16. Or wait, 19. Again, this is what happens when I wake up and worked all day on a long script and then try to stream. Okay, so let's pull this up for you guys. Okay, so nose coin deploy, 110 seconds, a minute and 10 seconds. Wait, and 100 debris at 110, about 10 seconds after. Wait, at 110, after nose cone deploy, that would be. Hang on. Okay, nose cone deploy. There's nose cone deploy. Nose cone deploy. So are you looking at this on the? Okay, we actually saw something almost exactly like that. I think that's exactly what you're talking about on the grid fin. So don't forget, as I mentioned this on my live stream, that there is a lot of ice all over these vehicles. There's likely ice that builds up in the rings. This looks exactly like there was a big hunk of ice that was built up around the ring on the, the kind of the flange that holds on to the actual grid fins. I don't really have a detailed enough thing, but kind of like this section here. There's this whole thing and it mounts onto the fuselage. And there's a pivoting thing and it will go like this, right? But that looks like that, and there could be ice built up there because it's a different shape than anything else. And these vehicles, don't forget, these rockets have liquid oxygen in them. Liquid oxygen is very cold, and SpaceX super chills it down below, I believe, below minus 200 Celsius. So it's really cold. There's literally ice on the outside of the vehicle. And there's going to be ice particles that fly off, especially on the second stage. When you look on the right screen, you're going to see little pieces of, I even noticed, look on the right here, you're going to see a chunk of solid ice oxygen kind of break off from that purge valve there. And you'll see it kind of moving around right around here. I don't know. I thought I saw it somewhere. But we actually, if you watch that stuff, you'll see bits of debris and bits of ice there. Look, there's going to be a piece of ice. There goes the nose cone. Bye, nose cone. The aerodynamic nose cone on top of Dragon. Bit of debris. There we go. A little bit of debris fell down there. I mean, a little more there. It's just totally normal. And especially now, notice on the right here, the upper stage is under acceleration. So it's experiencing more than a G of acceleration, likely about 2 or 3 Gs of acceleration. So if you were on this thing, you'd be getting squashed into your seat. So stuff that falls off while the second stage is under acceleration will be flying off of it, like you're seeing. You'll see little bits fly, and they'll fall, and they'll get kind of whipped just off into the distance. Now, this stage, on the other hand, because it's not under acceleration, anything that falls off will just float away, just like you'd expect things in space to do. It's just going to just float away. And notice that the upper stage is doing a few little precise maneuvers. So it is actually moving itself around a little bit, and that'll move it away from, or at least move it in a different velocity heading than the actual whatever piece of debris falls off. Because once something falls away from it and detaches, if it fires those little RCS thrusters like we're seeing, then they will not move together because they're not connected. It's just that when it's not, even though this is moving really fast, you need to remember it's moving really, really, really fast right now. The first stage is probably falling at still a couple thousand kilometers an hour. It's falling very quickly, but there's no atmosphere to have, to be pushing anything around. It's not going to be pushing any of those ice chunks around. And everything's relative velocity. So anything that falls off of a booster, even though it's going 2,000 kilometers an hour, the stuff that's falling off it is also going 2,000 kilometers an hour. And it won't really get whipped away or doing anything differently until it hits the atmosphere. Or, again, unless the first stage is doing maneuvers and moving itself away or just changing its velocity compared to bits of ice and stuff that fall off. Sorry, that was a really long rant. I hope that helps explain it. But I do like finding some of those things because they're fun to explain. But stuff in space is just kind of weird. All right. Okay. Hopefully that answers your question. Pete Martin, Tim. Oh wait, that was the same one. Sorry, Night Fox needed to make another super to correct myself on New Zealand. So embarrassing. It's okay, Night Fox. No big deal. Thanks again. We all make those mistakes. Jazzy Mac, almost 10 p.m. Hawaii. Rockets are better than sleep. Yeah, trust me. It's 2 a.m. where I am, and I am very tired. Thank you again, Jazzy Mac. Ruffinist, graduating with a BS. So I have a degree in BS. Graduating with a BS in astronautical engineering in a couple of weeks. Awesome. Stoked to start building rockets. Love your channel, bro. Well, congratulations and good luck, Ruffinist. We'll all be cheering for you. We need more and more engineers, and we need more and more people working on freaking rockets to get humans into space and to help us explore our cosmos and learn more about where we are in space. So thank you so much for working hard. I mean, that's impressive. That's really, really impressive. So everyone, wish Ruffinist good luck on becoming a literal rocket engineer slash rocket builder, technician maybe. So that's awesome. Joseph, any plans to make a Rutherford engine shirt? Ooh, I think it might be about time. I might have to come up with something kind of spicy for that. I think you're exactly right. I do like that idea a lot. Let me get my gears turning on a little bit and start thinking of something. I do love that little engine. I need to ask Mr. Peter Beck more about that engine because it's just a fascinating little thing. James Bramlett. That I should mention this. I feel like I always forget to talk about this sometimes when we're just talking about the Electron. The Electron is super different. It has like 3 unique technologies that make it very different. Well, besides this tiny little size, the whole fuselage and tank is the same piece of material, and it's all just a giant piece of carbon fiber, basically carbon composites. That's the first orbital class vehicle to be made entirely of carbon fiber, to not have any liners or anything like that, just straight up carbon fiber. So that's already awesome and impressive. They're also the first orbital rocket to use an electric turbo, well, not turbo because there's no turbine, electric pump fed engine. So they bring in the fuel in the oxidizer. In this case, it's liquid oxygen and RP1, which is the same type of fuel as, the Atlas V, the Falcon 9, and a lot of other rockets. But instead of using a turbine and a gas generator or a pre-burner to spin those pumps like I talk about, I have a lot of rundowns on that in my video about the Raptor engine. Instead of that, they literally just use electric motors and giant battery packs. And those electric motors spin up those pumps and feed the engines. And it's pretty amazing that they can get it to work. And they're riding a technology that's just improving. We all know that, not electric motors are pretty darn great, and they're probably near their peak, but battery technology just keeps getting better and better and better and cheaper, literally year over year. So they're on a technology curve that is a fun one to bet on. So we might actually continually see just slight upgrades to the vehicle. But I definitely would love to put it on a shirt because I think it's really cool. Okay. James Bramlett says, my favorite heterochromium. That's actually really hard to say. Thank you, James. You know how you felt when seeing that little kid dressed up as you? Yes, we get the same feeling seeing you in the shirt, not the giraffe though. Oh, in the suit. Sorry, not the giraffe though. I don't think that's true. Yes, I think that little kid in a onesie spacesuit was the most adorable thing I've ever seen in my life. But me wearing an adult wearing a silly spacesuit just as a joke, as it all started off with, I think the pictures and the art project is what it is and what it should have been. But me sitting here talking in a living room or in a bedroom or in an office, just wearing a spacesuit makes no sense. And I don't know. I think it can actually be off-putting. But thank you, James. Yeah, maybe someday for some kind of anniversary, I'll put it back on or something. Derek SP, will they do the helicopter thing? No, today I don't believe there's any plans to do any kind of helicopter recovery. They might have helicopters nearby to try to do filming and tracking of the vehicle. 11 minutes ago. Sorry, I didn't even notice this. Let me see if my countdown clock is accurate. That'd be amazing. 19 minutes, 16 minutes. It updated. That's incredible. Good work, Launch API. So let me show you guys this. The countdown clock has resumed. We're at 28 minutes for a target T0, running out of fingers launch. So yeah, we are, whatever time away now. I can't even really read that anymore, but yeah, 16 minutes. That sounds right. Cool. Hopefully, and I think they're actually live. Yes, they are. Make sure. Okay, I'm going to pull this up and get ready. And I'm going to hide that overlay again. Sorry about that. But I'll include the countdown clock if that works. Yeah, there we go. YouTube, we got this. Okay, so no helicopter today, just studying reentry and seeing how their system handles reentry. And then maybe the next step, if that goes well, would be, trying to pull the hypersonic balloon and the parafoil parachute. And then if that all works, I would assume flight 12, 13-ish, we'd see them. Oh, yeah. Flight 12, 13 is when I'd guess they'd maybe start trying to get the helicopter involved. Corona Kivo, how's it going? My thoughts on Starship Mark 1 blown its top. I'm going to say that. I talked about it on last week's episode of 2 weeks ago, the episode of Our Ludicrous Future. I talk about it. We literally kind of saw that coming because there had been rumors that they had been getting ready to move on from Mark 1 because it was such a, prototype build and literally just kind of like a fit test check vehicle. No big deal. It's honestly not a big deal. Literally probably won't change their schedule at all. And I think they were expecting to push it to the limits. Now, don't forget, the welds on Mark 1 Starship are nothing like the welds on future Starships. So you can't really take anything from that. Here we go.
Hello, everyone, and welcome to the live broadcast of Rocketlab's Running Out of Fingers launch. My name is Max Muncy, and I'm coming to you live from Mission Control here in Auckland, New Zealand. It's a special one for our team as it marks the 10th Electron flight since we began launching in May of 2017. We've called it Running Out of Fingers in homage to this milestone, and we're happy you've joined us for the event. To our friends, team members, and customers in the U.S., thank you for spending your early morning hours with us. Right now, it's 9:03 New Zealand Daylight Time, and we're 14 minutes away from liftoff at LC-1 on the Mahia Peninsula. We've got a 2-hour window today. You can keep up to date on our launch operations by following Rocketlab on Twitter and Facebook, as well as checking in on our website.
Sweet. Okay.
And at this point, confirm you're monitoring mission code and LE code.
Can confirm.
It's not 9
RCO
a.m.
flight mission.
Go ahead.
Please open the LC1 launch switch cover and confirm.
Switch covers up.
Please toggle abort switch. Confirm.
Toggle confirmed.
Okay, please keep the LC1 launch switch cover open from this time.
Switch covers up.
I feel like this is my time when I should remind you guys that the rocket itself is entirely black.
Confirm you're actively monitoring mission code range.
Listen to this. The entire rocket is actually black, but we see it as white and black right now because of that liquid oxygen tank. Liquid oxygen, again, very, very, very cold.
Today's flight is a commercial rideshare comprised of a diverse range of small sats destined for low Earth orbit. Unfortunately, there won't be live footage of payload deployment, but here are the details of the 7 spacecraft we're flying today. 6 of the 7 are comprised of 5-centimeter pocket cube pico satellites from satellite manufacturer and mission management provider Alba Orbital, which together represent 5 different countries heading to space. These picosats include a 2P payload from Advanced Technology of Laser, which is located in Hungary, that's designed to test a new thermal isolation material in space. There's a 1P pico satellite developed by Spanish nonprofit organization FOSSA Systems that uses low-power radio frequency to provide IoT connectivity. We've got a pair of 3P pico satellites from Star Space, which aim to demonstrate LEO-to-LEO inter-satellite link technology. These spacecraft are utilizing Alba Orbital's Unicorn 2 platform. Another Hungarian satellite, SMOG-P, a 1P picosat, this time built by students at the Budapest University of Technology and Economics, and it features a spectrum analyzer to measure human-caused electromagnetic pollution from space. The 6-pico satellite comes from a US-German software development company, Acme Atronomatic, and it has a satellite on board which will help the company provide flight tracking services to the aviation community and to mobile applications for things like MyRadar, which is a radar-based weather application for mobile devices. The 1P picosat also bears the logo from the computer game Star Citizen, a popular crowd-funded space simulation. The 7th and final payload on board aims to simulate the visual effects of meteors entering the Earth's atmosphere for a Tokyo-based company called ALE. The mission was procured by Spaceflight, a satellite rideshare and mission management provider. Today we'll be deploying our first payload to a circular 400 by 400 kilometer orbit at around 97 degrees inclination. After this deployment, the kick stage's Curie engine will reignite to reposition the stage in a 385 kilometer orbit to deploy our second payload.
Sweet. Look at the little guy.
And please disable recovery battery charging.
Just in case you're wondering, there are dropped frames
GC
from what
flight
I'm
mission.
seeing. I'm guessing,
GC.
don't forget,
Please send
the
pre-valve
Mahia
open
Peninsula where
command
this
and
launches
confirm.
from is very remote, so I wouldn't be surprised if there are some dropped frames in the feed. I don't know if I don't think it's on my end, but, you know, we can give a little grace either way if it's our feed or theirs. We're just excited to cheer them on and see what
Like me, I'm
happens.
sure a lot of you are excited about what this mission represents for Rocketlab's Stage 1 reusability plans. Back in August, we announced our plans to develop a system to recover Electron's first stage for reuse, and this flight marks a significant step forward in those plans. We've completed a block upgrade of the first stage, incorporating guidance and navigation hardware, including S-band telemetry and onboard flight computer systems. These new flight systems will gather data during the first stage's atmospheric reentry after separation from Electron's second stage. The first stage is also equipped with a reaction control system to orient the booster during its reentry descent. On your screen, you might be able to make out some of the new sensors and hardware we've installed in the booster to shape these recovery efforts. Today's first stage is a sacrificial booster, and we won't be recovering it, but the data we gather from this operation will help to inform our future recovery efforts. Now, we may be able to show footage from Stage 1's cameras as the booster re-enters the Earth's atmosphere, but this will be limited by the quality of the video signal at that point in the mission. During re-entry, you may see what looks like flames or a red-orange glow around the booster. This is completely normal and is expected. As the stage re-enters the atmosphere at 8.5 times the speed of sound, it creates friction with the surrounding air. This friction causes the air molecules to generate a very hot plasma, which can glow red or orange.
I don't know about friction. It causes compression and a bow
Avionics
shock.
flight mission.
Light avionics.
It's really
Please
the
cycle vehicle
compression
camera
of the
recordings and
air.
confirm.
Camera
Rather than
recordings
the
have been
friction.
restarted.
GC
I mean,
flight mission.
There can be air friction,
Like you
but
say,
what you see normally in
please
the
enable ground
plasma
high-speed
is
logging
from
and
actual
vibration
compression of air that gets
High-speed
trapped in
logging
front of the
and
wake of the
vibration
vehicle.
logging
The
are
front
And
bow
please
shock,
confirm
where
that igniter
there's
pressures
a
are
big
inbounds.
compression of air. It gets
Igniter
so
pressures
hot
are
it turns into
inbounds.
plasma.
Stage 1 flight mission.
What's stage 1?
Please
not a
confirm
big deal,
stage 1
but
tank
that's
press
just
set
kind of-
point locks
yeah.
400 kPa Kira 225.
Confirm both.
Stage 2 flight
Sorry, I'm
mission.
listening to what they're saying.
Flight stage 2,
Please confirm igniter pressures are inbounds.
confirmed.
And please confirm Curie catalyst preheaters disabled.
Confirmed.
Stage 2, please confirm the Stage 2 tank set points to 365 locks and 205 Kira.
Affirmative.
Avionics flight mission.
Light avionics.
Please confirm Stage 2 HVBs are enabled and hot swap is ready.
Stage 2 HVBs are enabled and hot top is ready.
And avionics, please confirm all Stage 1 HV batteries are enabled.
Stage 1 HVB bats are enabled.
Stage 2 flight on mission.
Flight stage 2,
Please confirm Stage 2 engine is ready.
confirmed.
And Stage 1, please confirm all Stage 1 engines are ready.
Confirmed.
It's awesome. Everything's looking good. Okay, so again, just to remind you guys, I was kind of talking about how the booster looks white and black now. It's entirely black. And what we're seeing, that white is actually just literally ice. It's ice buildup on the outside because the tanks are that cold, because liquid oxygen is that cold. Let me answer a few more of you guys' questions here. So no helicopter today, as they mentioned. Still really exciting. Corona, thank you again. Graham, I'd like to pitch that yourself, Ben, or Joe do a video on New Zealand's power grid and EV adoption. Over 82% renewable grid power and lots of Nissan Leafs. Really? Okay. I mean, it might take a trip down to New Zealand. I do really want to go back down to New Zealand.
Beyond our
Oops.
recovery plans, we've added another exciting change to our manufacturing processes to make weekly Electron launches a reality.
The robot.
Her name is Rosie, and she's a custom-built 140 square meter robot that enables the precision machining of Electron's carbon composite structures. This includes Stage 1, Stage 2, and the fairing. In just 12 hours, all marking, cutting, drilling, milling, and sanding is completed on a full vehicle. It's a job that used to take around 400 hours by hand. Here's our founder and CEO, Peter Beck, to tell you more about Rosie.
They do have this video online. And because of that, I want to keep answering your questions about this mission and stuff. So we'll just watch it. It's really pretty. But we can watch this video later anytime. So, yeah, I would love to go back down to New Zealand. I do actually have plans to try to go down there. again, maybe in 2020. It is amazing, and I'm just itching to go back, and I do want to see a Rocketlab launch from New Zealand. All right, Matthew Potts, proud Kiwi here. Thanks for all you do. 2 towards my Cybertruck, hopefully with the Mark 1 stainless steel. Thank you very much, Matthew. Tim C, hi from Rocketlab crew in Mahia. Awesome. Can confirm I did not fill Electron with lanolin today. I don't even know what lanolin is, but awesome. Congrats on being part of the launch crew. We're all cheering for you, and we're all so excited about everything you guys are doing. As you know, I'm a huge Rocketlab fan. And, yeah, I'm excited to go back down there and hang out again. You guys were awesome. So, yeah, good luck. Sir Billy Ritchie, I was talking about Soyuz successor yesterday. That's awesome. I don't exactly know what that's in reference to, but thank you, Sir Billy Ritchie. Maybe I missed something. But thank you. Raul Gosh, I'm 13 and planning to launch suborbital rocket to go past the Kármán line and carry and recover a small payload. Any advice? Pay attention to Rocketlab, because Peter Beck has literally done that exact thing. He was the first person in the southern hemisphere to get to above the Kármán line in the southern hemisphere. So pay attention to what he's done in his past and learn from him, because he is awesome.
Next 12 months to keep up with our production demands. There are roles in our New Zealand and U.S. locations, including at our second pad, Launch Complex 2 on Wallops Island in Virginia. Work began on LC2 in February, and in just 9 short months, more than 1,400 cubic yards of concrete have been poured at the site. Recently, the 65-ton launch platform was installed into its final position, and the 44-foot-strong back has been mounted and secured, ready to support Electron on launch days. Work has now moved on to testing, commissioning, and integration of the site infrastructure and preparation for the first Electron launch from U.S. soil, slated for early 2020. LC-2 will bring a new launch capability to the nation and is tailored specifically for government missions across science, research, and national security. A huge thanks to the teams at Virginia Space, Mars, and NASA Wallops. The drive and dedication you and our many local suppliers have shown has been key in helping us build this pad so quickly. We can't wait to officially open the pad in December, with our first flight scheduled in the coming months. As you can see, we only have 4 minutes left in the countdown, so I'm going to hand you over to Mission Control, and I'll be back with you just after liftoff.
Okay, I did need to make a quick correction. Peter Beck wasn't the first person in the southern hemisphere to reach the Kármán line, but I think he was the first private citizen, like because there was a bunch of stuff going down in Australia back in the day, and also, yeah. So thanks for the correction, Alley Cat in our Discord. Yeah. So okay, let's keep answering you guys' questions here. We got 3 more minutes. So good luck, Raul. We'll be cheering for you. It's really hard though. Just letting you know, but that shouldn't stop anyone from anything. So learn, read up. A lot of people have done stuff like that, and listen to what people say, because I think a lot of people are always like, well, I'll just do this. Like, I'll just stick it on top of a balloon. That type of stuff. So learn from those that have laid that ground before you, and good luck. Iconium 9000, would Electron benefit from a Methalox engine? I'm not sure. They'd have to run those numbers. There's likely, actually, it maybe would benefit from Methalox, and also just to be fully. If I talk to Peter Beck in the near future, or next time I run into him or talk to him on Twitter or something, I'll ask him about Methalox, because it seems like something like the Rutherford could actually switch out propellants relatively easy. I'm not going to say easy, but relatively easy, and probably easier than an actual pre-burner / gas generator system. They should have a lot more flexibility. All right. Now I'm not entirely sure again what benefit it would have. Besides, it could probably for sure have higher specific impulse. It could also be carbon neutral, which would be a good thing, and cheaper too. Cheaper to fuel up than RP1. RP1's expensive. All right, good question, Iconium. Hey, remember that question. Put it in. Okay. Let's see. 2 minutes left. So this is from Animated Sky. My dream podcast is you, Scott Manley, Elon Musk in a starship around the moon. So get on it, man. Jeez. It'd be a long podcast. That would be crazy and kind of scary and terrifying, but it'd certainly be nerdy. it would be very, very nerdy. That's for sure. So thanks, Animated Sky. Tobias, launch live audio perhaps? Can't keep YouTube in back. Launch live audio perhaps. Can't keep YouTube in back. Sorry, I'm not entirely sure what. Yeah, we'll have it up for the launch audio once they're actually going.
PLS flight on mission. PLS cut. Please to say you guys are in.
Pressing Kiro.
Chazzy Mac, almost sunrise. No, unfortunately, this is sunset. So the sun has already set, and they're just going to be flying into the darkness. And yeah, sunset. Here's another $2 for your mistake. Thanks, Chazzy Mac. Let's listen in here on the rest of the. Okay, I'm going to read these later. I'm going to listen into the final checks and make sure we're actually going to get out of here on time. This would be awesome. 40 seconds.
Galley's running.
The
Reading
deluge
GNC
is
systems.
the water deluge system that it's pouring water onto the launch pad.
Rereading engines.
Few drop frames here and there, but it's no big
10,
deal. We know the
9,
drill. Here we go.
8, 7, 6, 5,
Okay.
4, 3, 2, 1.
Yes. All right. All right. I don't know why that's. Oh baby, that's just a lens flare. A lot of people think that's something falling off the rocket. Just a lens flare.
Beginning pitch over.
That thing cooks.
Stage 1 propulsion is nominal.
Go Rocketlab. Go baby, go.
Enter check run 1.
There it goes. Rocketlab's 10th Electron has now left the pad and is on its way to space. With over 1 million horsepower at its back, running out of fingers will quickly reach the toughest point in its battle against
battery
physics,
discharge normal.
the moment known as maximum aerodynamic pressure, or Max 2. So let's check in on Electron's performance.
Enter chevron 2.
Vehicle is supersonic.
All right. We're about halfway
Approaching
through
max Q.
first stage burn. Everything's looking good so far.
Cleared max Q.
I love that space. It's so cool. I want to watch the launch from there. Actually, I'd rather watch the launch from the Mahia Peninsula, but second choice would be in mission control. Notice the exhaust plume
Guidance
again
is nominal.
getting wider. They have 9 engines just like a Falcon 9 that we saw earlier today, so you're seeing that very similar pattern of the
We've
exhaust.
made it past Max Q, and Electron
Getting
continues nominally. Soon the 9 Rutherford engines on Electron's first stage will shut down ahead of its separation
AOS
from
chatting
stage
station.
2 and its descent back to Earth. It will be our first attempt at a
Stage 1
guided
propulsion
atmospheric
holds
reentry of the
nominal.
booster,
Prepare for MECO
and we're hoping to be able to
approximately
update you on how that goes after the mission. Once Stage 1 and Stage 2 have separated, the final vacuum-optimized Rutherford engine on Electron's second stage will come to life and propel Electron the rest of the way to orbit. Let's check back in on the operators in the lead up to stage separation and Stage 2 ignition.
Staging in 15 seconds.
Entering burnout check mode.
Stage 1 MECO.
There we go. Stage 1 MECO. This is good.
Stage separation succeeded.
Stage 2 ignition.
All right. Awesome.
Recovery telemetry nominal.
Oh, that's so cool that we actually have shots from
Main
the
engine
interstate
cutoff
now.
is now confirmed, and Electron's first and second stages have successfully separated.
Guidance is nominal.
Soon the fairing will
Speed
separate
is
and jettison from
2.3
Electron's kick
kilometers per
stage, so let's
second.
watch.
Altitude 104 kilometers.
All right, so we might see the
Fairing separation
fairings. There we go.
succeeded.
Fairings, there they go. Bye-bye, fairing half. That's one. And the other one, I assume, is just out of frame.
Stage 2 propulsion
there it is.
nominal.
Looks like we've
bottom.
had a successful
HVP
jettison of the
battery
fairing.
discharges.
With that out of the way, we're now 50 minutes away from the start of our scheduled payload deployment.
Notice it is kind of sparky, and again, I want to confirm. I believe it's actually just, if I remember right, there's a little bit of copper lining, and I don't think it's necessarily the ablativeness of it. It's just kind of normal sparks. That's all normal.
As you can see on your screens, Electron's second stage Rutherford engine continues to burn bright as it propels its payloads into orbit.
Okay, I'll be answering some of your guys' questions
And
after
on the
this.
left, we have visual of Stage 1 during its first controlled re-entry into the Earth's atmosphere. The data we receive from this guided re-entry will aid in our future recovery plans. We'll continue to broadcast this view as long as we
Stage
can
2
for you.
propulsion is nominal.
Good for you, Rocketlab. Thank you for bringing us along on this literal ride. We are... Oh, that's so cool. So again, on the left, you're looking down the
HVP
rocket.
battery discharge is nominal.
And they do have little tiny RCS thrusters and things like that. I'm trying to figure out what that extra light would be. Oh, maybe that's light from like the moon or something. Is the moon out tonight? It wouldn't be the sun because they flew east into darkness. So maybe that was a
The
little
next
bit of
milestone
lens
to
flare.
check off is one that's unique to Rocketlab and Electron. The Rutherford engines are powered by electric pumps. Electron is in fact the world's only orbital launch vehicle with this feature. These pumps are powered by batteries, and as you can imagine, it takes quite a bit of power to reach orbit. Initially, a pair of batteries serves as the power source, but once these are depleted, we swap power over to another fully charged battery and then jettison the depleted ones. We call this process the battery hot swap.
Man, they've got some good cameras on that left stage if it's that well lit without sunlight. I'm guessing that's the moon. And that is an impressive camera they've got on there. Although, wait. That's definitely appears to be Earth visible. So maybe they're high enough. They must be high enough that you can actually... That they made it sunrise again
Guidance
for
is
basically.
nominal. 185 seconds remaining.
Yeah, I'm confused.
Electron's velocity is 14,000 kilometers per hour, and our altitude is 200 kilometers as we approach battery hot swap.
HVP battery discharge nominal, approaching hot swap in roughly 30 seconds.
This is amazing.
The APS has saved.
So we can't really see the RCS thrusters firing off. That is guiding and controlling the first stage on the left. I was expecting to kind of see the little puffs. They do have little tiny RCS thrusters. There's a chance those RCS thrusters are behind us. You can tell we're starting to get into atmosphere
Hot
now.
swap
Look at
successful.
some of the ice starting to hit the air or hit the atmosphere. Just like we talked about earlier, how relative velocity. Now you can actually see stuff. Oh, okay.
As you've
Stage
just
two
heard, we've had
propulsion is
successful
holding nominal.
battery hot swap. Electron's second stage engine
Recovery system
continues to burn
reorientation
6
successful.
minutes and 45
Enabling
seconds
access
into the
imminent.
mission.
Oh, it cut out already. Come on, baby. Come on. No. Oh, that was just getting pretty. Oh, if they went straight south, you're right. 90-degree inclination, they would have gone straight south. That's so they very easily could have actually popped up and been able to see the sun. Oh, that was so cool. That was a beautiful, beautiful view. I really hope that they're able to recover some of the footage from that somehow and get it. Because that
We're currently
was awesome.
7 minutes, 15 seconds into flight, and with the mass of the depleted batteries out of the picture, Electron now has a much more efficient ride to orbit.
Okay, so
All systems are nominal as we approach second engine cutoff in around 40 seconds. Our velocity is 21,000 kilometers per hour, and our altitude
HVP
is
battery discharge
204
holding nominal.
kilometers.
look at how fast the baby's cranking out now at the end, near the end of the burn. Oh, that's a cool view. I think it's that they're flying basically due south, so now they're actually...
Shortly we'll have cutoff of the vacuum-optimized Rutherford engine on Electron's second stage, followed by separation of the
Guidance
kick
is
stage.
terminal.
Let's check back in with mission control.
Yeah. let's
Entering
spin back.
stage 2 burnout detect mode.
Oh, that's such a cool view. I love looking forward as it's accelerating. I don't think I've ever seen that. Look at that. Due to the...
Stage 2 shutdown.
Yes.
Vehicle is in transfer orbit. Apogee is 385.97 kilometers. Perigee is 186.01 kilometers.
Sounds bang on.
Inclination 97.01 degrees.
9701. Wow. That is precise. 97 is what they're aiming at. They got 97.01 degree inclination. Whew. That's impressive. That's impressive. Not true, Alley Cat. Not all Rocketlab launches are polar inclination. They can fly.
And we have confirmation
38.
of kick stage separation. Electron's running out of fingers mission is now orbital. As I mentioned at the beginning of the webcast, we won't have live footage of payload deployment scheduled approximately 45 minutes from now, but you can follow us on Twitter and Facebook for confirmation that all satellites have been deployed. Before we leave you, a final thank you to our mission partners for choosing to fly with us on our 10th Electron mission and final launch of 2019, and a massive congratulations to the Rocketlab team on 10 flights. It's been a huge year for us with 6 orbital missions. We've got planes to look forward to in 2020 with our first launch from LC2 in Virginia, the first launch of Photon, our customizable satellite bus, and of course our future recovery attempts of Electron. All this means there are still plenty of exciting career opportunities here at Rocketlab. If you've ever thought about joining our world-class team, head to rocketlabusa.com. Thanks for the ride in 2019, and we'll see you back here in 2020. I'm Max Muncy. This is
right.
Rocketlab Mission Control.
We have a lot to
signing
talk
off.
about. We have stuff to talk about, ladies and gentlemen. First off, okay, everyone, congratulations to Rocketlab. We don't need the countdown clock anymore. That was awesome. I am going to actually rewind before we do anything else, and I got to see that reentry again. That was so cool. That was one of the prettiest reentry shots I've ever seen. And I've seen quite a few. I've seen literally every one of SpaceX's shots. It's just cool to see it from a different provider, too, though. Okay, hold on here. I was going to make a joke that... Okay, hang on. Look at this. This is cool. So someone was saying, you know, I saw in the chat, someone was saying that it looks like it's awfully sideways. It is. It's not going to be coming straight back down. It's on a parabolic, you know, arc. So it launches and goes over like this and pitches over. And so the vehicle actually stays on that arc trajectory. So it's actually going to be coming in at an angle. And for a while, it's flying straight sideways, straight 90, you know, parallel basically to the ground. I was also going to make a joke that that concave Earth confirmed in that one shot that I was looking forward is really pretty. But it's just funny. I wanted to explain the warpedness of a fisheye lens. Where was that shot? It was really cool. I'm just going to do a little bit of scrub-a-dub-dubbing. And there we go, this one. Well, it got better in a second, I think. I love that shot, though, where we're looking straight. Okay, right here. Notice that not only is the Earth apparently flat, it's also inverted. No, this is, remember, this is a perfect example right here of what happens when you have a fisheye lens. So this is a camera that's mounted on basically the top of the rocket looking straight forward on its x-axis. Now rockets you'd think it's the z-axis, but it's not. Rockets go x down the length of it. Z and y are pitch and yaw. The roll axis is x. So we're looking straight forward on the x-axis. This satellite, pretty safe to assume it's not curved in real life. It's straight. It'd be a cube of some kind of square. And because of the distortion of a fisheye lens, this is an ultra-wide fisheye lens, it will curve things more on... This is actually a perfect example of this. It'll curve things more on the outsides, including all angles, the left, the right, the top, the bottom. And as you get closer and closer to the center, straight lines become curvier the further away they are from the center, basically, is how I'm going to say that. I used to be a professional photographer, so I had to deal with lens distortion all the time. Notice that what's in the middle of the frame is basically perfectly straight, and things that get closer to the edges begin to curve more and more and more, and they curve in like this. So the same thing's happening with the Earth here. The Earth is actually curving the opposite way ever so slightly. We're only at 200 kilometers in altitude, so not that high, which is 120 miles in altitude. And basically, because of that fisheye distortion, it is actually curling it backwards. So if you were wondering why that looks that way, that's why that looks that way. I don't know if I needed to explain that, but it's just kind of fun. So, yeah, I would love to see actually a perfectly a spherical lens, a lens that rectilinear, like a lens that doesn't have, not rectilinear, a spherical, I think is the right word. Sorry, it's been a hot minute since I've done a photo gig, but yeah, where even as long as it's, even if it's ultra wide, it keeps everything straight, and those are typically a little more expensive, but pretty cool. Okay, so let's answer a few more of your guys' questions. Okay, so when can we see a toque in your store? Oh, wait. Oh, Derek SP, I missed yours first. Elon Musk on our ludicrous future when? I don't know. That would be, I wonder how that'd be if all three of us were talking to him. If that would be crazy. If it'd just be like, we'd all be talking and he wouldn't even talk. Maybe it's Joe's turn soon. Maybe it's Ben's turn soon. I've had a chance to talk with him. So I think we split him up because otherwise, you know, we want to hear him talk. If there's three people talking at him, there's a chance that he just won't talk as much. Chad Omen, when can we see a toque in your store for us poor frozen Canucks? Actually, hopefully in like a few weeks. I think it won't be something that would be available for the holiday season, but it is something that's coming out this winter. So stand by. I've got you covered because I live in, pretty far north where it's also very cold. NATO Nathan, hey Tim, could you build a Starlink style constellation in KSP? I could. It'd actually be really hard. Actually, it'd be easier to just put all of them up in a thing. It'd be pretty hard. I don't know if I would be able to do it very easily or very accurately. Scott Manley would probably be able to do that in a heartbeat though. Like programming and all and everything. Yeah. Let's see. Good question though. Tobias, compression thing bugged me too. Soyuz always turn white. Yeah, is that a video compression thing where Soyuz ends up looking white? I have never actually considered that. But yeah, there was a little bit of compression today and latency and dropped frames in today's live stream, but we'll give them a pass because they just, put a satellite into orbit and are working on recovering their first stage. I think that's a little more important. Let's see. Dash Riptide. Lanolin is the oil from sheep's wool that makes it soft. Sounds like a joke considering New Zealand has a lot of sheep. That's right. That's okay. I'm glad that they did fill it up with RP1 instead of lanolin. Thank you so much. Cuba, hi Tim, great work. There is one thing about booster I can't understand. How is Falcon 9 reignites its engines to deaccelerate if fuel is floating in the tank in 0G after separation? Saturn V had Ullage motors. That's a great question. So you'll notice there's a few things at play here. So first off, there aren't Ullage motors or Ullage motors. I believe they're pronounced Ullage motors. I pretty much only read that. But the thing is, they also have those cold gas thrusters at the top of the inner stage on the Falcon 9 booster, which can shoot straight down. And that can actually help settle. All you need to do, you don't need to accelerate much. You just need to settle the propellant into the bottom of the tank. So you can have just a very, very, very small amount of thrust. On the actual flip maneuver, if you think about it, because they get to that boost back burn really, really quickly on the Falcon 9. It separates, it turns around and turns and burns and goes. And because of that, and that would actually likely throw everything in the opposite direction. But I think the other thing, I don't know this for sure, but they first spin helium through the pre-burners. And I'll bet just turning on the helium system and getting not the pre-burners, but the gas generator, getting the gas generator spinning, I'll bet just that alone accelerates the vehicle enough. Then they ignite TTEB, and that will ignite that's pyrophoric, so it ignites once the liquid oxygen starts flowing. So I would guess that they avoid hard starts and avoid pulling in air bubbles into the tanks just by firing up the helium and getting those pumps spinning that would settle the fuel long enough to be able to suck up some liquid oxygen, hit that T-tab, and get a nice clean burn without a dedicated ullage motor. On reentry burn, though, by the time they do a reentry burn, there's already enough air resistance that's slowing the rocket down, that's actually providing a force of a change of acceleration, a change of velocity. And in doing so, it is experiencing some G-force, and that will settle the propellant as it does experience resistance against the atmosphere. So the only one that I'm a little confused with is when it's full-blown in space, like the flip maneuver and the boost back burn. That one I'm not entirely sure how they pull that off, but it's a pretty cool trick. Maybe I'll see if I can't get more info on that someday. All right, the LOL Minecrafter. What do you have to say? What do they mean by sacrificial booster? Well, pretty much every single booster ever besides the Falcon 9 and the Space Shuttle's SRBs were sacrificial boosters, meaning they go bye-bye. They deliver the second, they get the second stage going normally about a quarter to maybe a third of its velocity. And then the second stage or the first stage goes bye-bye and it gets sacrificed into the ocean. It's no longer a thing. This is still a sacrificial booster because it's collecting data, but it's kind of for the greater good still. And it's just very tongue-in-cheek. And LOL Minecraft also asks, what kind of fuel will they be using? What kind of engine is equipped on the rocket and booster? So looks like you would be prime. First off, welcome. Second off, check on everydayastronaut.com, and we give you a rundown on these vehicles. This is the Electron, and although this doesn't necessarily tell you exactly what it is, actually, you know where you need to go? Go to YouTube. Look up Everyday Astronaut Rocketlab, and you will get a very good rundown on this entire vehicle. It runs on RP1, so basically jet fuel. It runs on electrically fed pumps, so as opposed to a pre-burner or a gas generator. So yeah, I go into all that in that video. I'll give you a really deep rundown. It's a really, really, really unique rocket. There's 9 engines on the first stage, a single vacuum optimized engine on the upper stage. Yeah. Stefan, thank you so much for the pair with some coffee. Brian, can Rocketlab launch one human into space? Is there enough room? I mean, technically they probably could. It'd have to have a very, very, very minimal everything, because it can deliver 250 kilograms. They could definitely do a suborbital launch if they wanted to, easily, and put actually a pretty healthy little capsule on top of just the first stage and boop, let it go. But Peter Beck has said over and over, he's not interested in flying meat, so he does not want to fly people. His interest is these small sats that are under 250 kilograms. That's his market. That's what he's going for. He's very focused, laser focused on that market and fulfilling that need, which is a growing market. They've got it nailed down. I don't think they have any interest and will likely never fly humans. So, but there would be enough room. The fairing is pretty decent sized. You could sit in it pretty tight, like a little tiny Mercury capsule or something. But yeah. Thank you, Brian. Puffy Cheeks. Yo, how many Joe Scotts you fit in space? Like 3 or what? Space big, yeah. How many Joe Scotts? Does Joe Scott fit in space, or does space fit in Joe Scott? Okay. Derek SP, are you going to host today's Soyuz launch? No, so I still haven't done a Soyuz launch, and it's getting close to time that I do, because I finally am getting familiar enough with the rocket. It's just one of those systems, one of those things that has so much history, so much heritage. I could mess up. I could say something just super wrong, and I don't want to do that. The reason I'm comfortable doing ULA, SpaceX, Rocketlab is because I've literally covered these vehicles. I've done in-depth rundowns. I know them very, very well. I've literally touched them often. Not often. That sounds weird. I've put my hands on a lot of these vehicles and actually am very familiar with them. I have never really done an in-depth rundown on the Soyuz vehicle, and I will on the R7 variant, but it's just one of those things I just still don't know enough about I want to be able to casually talk about stuff and casually answer questions. And if people are like, why is the third stage using blah, blah, I'd be like, I don't know. It's important for me to be accurate enough to be able to answer things on the fly. So for now, I will not be doing a Soyuz launch? Sir Billy Ritchie, this is a good question. Would I ever do a video about the countless proposals Roscosmos has had to replace Soyuz? Speaking of Soyuz, that's a great idea, honestly. Yeah, I would absolutely love to do that because there have been so many things. I did do a video about the TK spacecraft and the, oh God, what's that thing called? On one of my canceled videos, I talked about the Liberty, or I don't remember what it was called. But they did have a totally separate crew module that was ready to go and never ended up flying people on it. And it's just crazy. There's been so many proposals, and for better or worse, Soyuz is still with us and still kicking and still super, super reliable. So, yeah, thank you, Roscosmos, for still having the Soyuz, still getting us safely to space. So, yeah. All right, Tobias. Plasma compression, not video. Oh, people think friction. Soyuz turned white due to 2 locks as Electron. Would love this stream as audio. Out of money buy. Thank you, Tobias. Plasma compression. Gotcha. Yes. Yep. Yeah. Awesome. Thank you, Tobias, for clearing that up. Mr. Hitman, someone... not reading that for sure. Okay, interesting. Jarrett, should I be drinking Sunkist, eating Cheetos, watching you and Space Renaissance unfold in the middle of the night as if it is a movie premiere? Yes, you should. You are in the right place. Thank you for saying hi, Jarrett. And, oh, it looks like there is some Twitter stuff going on. Let's check Twitter, see what they say. Electron made it through wall, solid telemetry all the way to sea level with a healthy stage, a massive step for recovery. No way. Congrats. That's huge. I can't wait to hear more about it. Oh, that's awesome. That's amazing. Wow. Huge first step. Can't wait for flight 11, 12, 13, etc., etc. Exciting times ahead. Now you guys know what it sounds like in my head. And then normally go blah, like this. But for some reason this isn't working as well. I like this one. There we go. That's amazing. Dang. Welcome to Watch Tim Tweet Live on the internet at almost 3 in the morning. I need to go to bed. Yeah, that's going to do it for me, guys. I'm just going to call it a night. Congrats again, Rocketlab. Congrats to the payloads. Yeah. What a great time. 2 launches in 24 hours for me. That is awesome. I'm really excited. You guys need to stand by. If you're still watching right now, there's still a few of you out there. Listen up. I will have an awesome video for you in less than a week. Hopefully by, I think, about Tuesday, it will be out about whether or not Starship should have an abort system. It's going to be an awesome video. I got a lot of questions about it, especially when we saw Mark 1 blow its top. So I do talk about that. And I'm really excited to answer that question because I didn't know all of the answers, but I found a lot of really good data. We literally look at the number of times that an abort system has ever been used, ever been saved someone's life. We look at the total reliability of rockets. We look at the certification. We look at the flaws of the space shuttle. We look at if there's any flaws that are similar to the space shuttle that are in Starship, if not having an abort system on each of those. It's going to be a 40-minute long video, like half of mine end up being these days, but it's going to be amazing. Hopefully you'll learn a ton. I learned a lot writing the video. The script's pretty much done. I'll be shooting it tomorrow, and then hopefully getting a wrap on it by the end of the weekend or Monday or Tuesday. So stand by for that. Yeah. Can't wait for the toe flight, says 2A. That's funny because they're out of fingers, so they'll need toes now to count. And Derek, are you Tim Allen from the show Home Improvement starring Tim Allen? I am not, but I think I wish I was. I don't know. Yeah. One more reminder real quick, if you guys want to help me do what I do, please shop around everydayastronaut.com/shop. Check out the awesome merchandise we have in stock right now. Again, if you work for Rocketlab or an aerospace company, click the link below in the description here. You can receive 25% off apparel as my thank you to you for doing awesome things and helping us go and explore the cosmos. You'll just have to put in a work email with a verified domain. It'll pop you a code. I don't keep that email or anything. There's no lists or anything like that. And ta-da, you will then have 25% off any apparel as my thank you to you. So thank you for working in space and making humans explore and learn more about everything and doing awesome things. So I wouldn't be doing what I was doing if it wasn't for you guys doing actual awesome rocket science. So thank you. Also, if you guys want to help support what I do, patreon.com/everydayastronaut, where you can join our exclusive Discord channel, our exclusive Reddit, and get exclusive live streams as well. So I need to go to bed. All right. Thank you guys so much. That's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Bye, everybody.